Okay, Algebra 1, we have a short section today, 3.2, solve two-step equations. So here is an equation that has two different things going on, and we need to isolate x. So jot it down, and what would be your first step in isolating x? Good, you're saying subtract 9, right? So when we subtract 9 from both sides of this equation, we're using the subtraction property of equality, right? Let's see if I have a line here and make this easier. So I'm going to put a little line here. And now when we simplify this, we have, on the left side, we only have 5x, right? 9 and negative 9 end up leaving us with just 5x. Okay, equals 24 minus 9, 15, right? Okay, the second step would be to get rid of this multiplication of 5. And we would do that by dividing by 5, right? Divide, the inverse of multiplication. And when we do, we now have 5 over 5, which is 1x, right? X equals x. I'm going to squeeze it in because I've got some information under the screen. So x equals 15 over 5, which is 3. Yay! Okay, let's think about the order that we undid these operations. We undid the addition first and the multiplication second. Now, if we knew the value of x, which operation would we perform first, multiplication or addition? And I hope you're thinking of our familiar order of operation acronym, PEMDAS, right? We would do multiplication first and then add. So when we don't know the value of x, we actually undo the operations in reverse PEMDAS order. Isn't that interesting? Oh, excuse me, I gotta go get my cupcakes. Okay, very good. Let's try this again. Solve for x. X over 4 minus 3 equals 2. And go ahead, pause the video and come on back. Once again, if we knew the value of x, PEMDAS, we would do division before subtraction, right? But we don't. So to undo these operations, we will do the inverse of subtracting 3, add 3, and we must do that to both sides to maintain equality, right? So when we simplify now, we end up with negative 3 and positive 3, 0, right? So we have x divided by 4 equals 2 plus 3, and 2 plus 3 is 5. All right, and now to undo this operation is division, right? So the inverse of dividing by 4 is multiplying by 4. Very good. So we'll multiply both sides by 4. And when we do, 4 over 4 equals 1, right? And we end up with 1x equaling 20. And there we go. And remember how we can check this? Plug it in, right there, right? So if we plug in 20, 20 divided by 4 is 5. 5 minus 3 is 2. And yes, we've checked it out. Very good. Okay, let's see. We need to combine like terms first if we received a little more complicated equations. And then we'll simplify and solve. So in this example, we have the left side of the equation it's in a position to be simplified, isn't it? We have 5b's minus 7b's. Okay, it's like I have 5 boxes minus 7 boxes. These are like terms. They have the same variable to the same exponent. What is that invisible exponent that they each have? 1, right? That invisible 1 exponent. So right now we are going to combine these before we solve for b. So think about it. What is 5b minus 7b? Now we learned that we can add the opposite, right? So 5b plus negative 7b is, you guys are good at this, negative 2b, right? Negative 2b, it says equals 4, okay? And now we're in just a simple one-step equation, right? The inverse of multiplying by negative 2 is dividing by negative 2, right? So divide both sides by the same value, division property of equality. And we end up with negative 2 over negative 2. That equals 1, right? 1b, we don't even need to show that 1, equals 4 divided by negative 2. Positive divided by a negative is a negative. 4 divided by 2 is 2. Good. And so let's see if the solution makes sense in the original equation. We could put it actually right back in the original. 5 times negative 2 is negative 10, right? And 7 times negative 2 is negative 14. But remember, we were subtracting this value here. So it's as though we're saying negative 10 minus the negative 14, or negative 10 plus 14, which, yes, it equals 4. Good job. Let's just look at one word problem, and then you can be on your way today. So pause the video and take this scenario down. It says renting a booth at the county fair costs $42 per day plus a one-time equipment fee of $85. Find the number of days Mr. B rented a booth if he pays a total of $337. Please write this scenario down. We'll use Queen Fiona. Okay, our 5-step plan. Queen Fiona uses outhouse seats. So Q stands for what is the question? The question here. And find the number of days Mr. B rented a booth. Okay, so let's just jot that down. Number of days. And a variable we could use for that might be, you're probably thinking n, right? Number of days, n. Okay, that's the question. The number of days he rented the booth, right? Okay, what are the facts? Let's see. One fact is we have the cost of $42 per day. Whoops, day. Another fact is he has this one-time fee of $85. And is there another fact? Oh yeah, he has a total cost, total of $337. Good. Okay, I think we need all of those things. How about any unnecessary facts? Any unnecessary numbers? No, I don't see any. And then operations. This is tough. Okay, what operations do we need? Well, whenever we have a rate like this, $42 per day, 2 unit forms with 1 number, we usually are going to take that rate and multiply it to something else. So multiplication is probably one of our operations. When we have a one-time fee, what will we do when we know in order to find his total cost? We're probably going to have to add that, right? So addition to the number of days and so on, right? So I'm thinking we need multiplication and addition. And finally, the goal is to write the equation. So pause the video, see if you can write the equation for this real-world problem, and then come on back. All right, so if you used unit analysis, you probably wrote $42 per day, right? And I said we'd probably be multiplying that to the number of what? Look at the denominator. It would be something that could cancel out with days. So it's probably n days, right? N days are unknown, right? And one is plural, one is not. So let's make that one singular as well. So we're going to multiply 42 by the number of days, if only we know them, right? And we'll know how much was paid just for this rent, right? If he rents the booth for 1 day, we would plug a 1 in here. 42 times 1 is $42, 1 day, right? If he rented it for 2 days, we could plug in a 2 here. 42 times 2 is $84 for 2 days. This makes sense, okay. And then we're going to, we have to remember this one-time fee. So if he rents it for 1 day, he pays $85. If he rents it for 100 days, right, he still would pay the one-time fee. So as we said, we'll probably add that in. One-time fees are not multiplied to anything. They just are one-time fees. There it is. And if only we knew the number of days, this total should equal the total he paid, $337, right? Very good. So at this point, we're ready to solve. This is the beautiful equation that represents this real-world problem. If we wanted to now remove the units to just get down to those numbers, it will look like a very familiar equation. 42n plus 85 equals 337. It looks like the equations we were just solving, doesn't it? So go ahead and undo operations. The first operation that we would undo is, right, the addition, right? So we're going to subtract 85. And don't forget, we got to do that to both sides to maintain equality, right? Subtract 85. And when we do, we'll have 42n left. 42n, no more 85s, right? Equals, what is 337 minus 85? Well, that would be 250. Oops, it's not showing up. Let's see. 2. Where's my keyboard not working here? 252. There you go. All right. So, how do we undo this? This is which operation? Right, multiplication. So to undo it, let me underline it, and I'll underline this side as well. We're going to divide both sides by 42, right? Over here, divide by 42, and when we do, we should have n nicely isolated, right? And so we can say that n equals, let's see, 42 going into 252. Can you go scratch that out? And when you do, n equals 6, right? So 6 days. Okay, so there's your answer, 6 days. That sounds reasonable, doesn't it? And when you substitute 6 back into the original equation, 42 times 6 gives you 252, and 252 plus 85 is 337. So don't forget to check your work. Okay, excellent. So again, put your best effort in, and it will pay off. It will really pay off for you. And so here you go, and have a good time.